If you haven't at this point, you should go ahead and work the remaining sample problems in the notes and do the best that you can on them based off the prior information. When you finish, come back and watch the remaining 3 videos just to see the solutions worked out. Okay, for sample problem 4, I'm going to do a couple things here first. I'm going to go ahead and I'm going to start with the Descartes' rule of signs, and then I'm going to move into the rational root theorem and go on from there. Okay, so I've started off here. I'm just going to use the original problem for my positive roots. So you can see here I have one change and then I have a second change. So that's 2 possible positive roots or 0 possible positive roots. On my negative, I have 1 change. So I have exactly 1 negative root. Now there's supposed to be 3 total. So if that's the case here, I've got 0 imaginary, or I have 2 imaginary. So that gives me a little lead in to what my potential final answer could look like. Now, I need to go ahead and come up with all of the possible rational roots. Okay, and hopefully by this time you're starting to get more and more comfortable listing out these roots. As you can see here, I actually skipped the step of doing the P and the Q individually and just went straight to all of my possible rational roots. Now, again, this is a great opportunity to use your calculator to come up with an eyeball visual on what the possible roots are. As you can see, I'm going to use the 1/2. Now, what you'll notice about the picture on this graph is they crosses the x-axis 3 times. So I know I got 3 real roots, which tells me that I'm going to be using this scenario up here. Now, what that probably implies to me is that one of the real roots is positive, is a rational root, and then I have the complex conjugate, the conjugate pairs theorem taking place here with an irrational root. So I need to do, it's hard to kind of guesstimate, but it looks like 1/2 is the best 0 we have, because we know that's not going to be 1, 2, or 4 because our graph doesn't give us a perfect integer anywhere. So I'm going to go ahead and set up synthetic division for 1/2. And we can see that we end up with a 0, which is what we were looking for. Now we'll go ahead and start to factor out the linear term and work down from there. I'm going to go ahead and take the factor of 2 from the trinomial and apply it to the binomial. And because I have a pretty straightforward trinomial here, I'm going to use completing the square to finish this problem off. Okay, now we have all of our roots or zeros or solutions to this particular cubic. Hopefully that went well for you.